Okay, good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Comics titled Nurturing Habits of Mind Through Intermediate Math Inquiries with Maria Van Vallis. We have a relatively small group tonight, as I've seen, with mostly experienced participants, and small groups are always a great opportunity to foster participation. I find that small sessions are often more interactive, and I certainly hope that it will be the case tonight. Maria's sessions are always of a very high academic level, and she tends to address her sessions to a fairly small audience. But to be totally honest with you, we are actually running another webinar tonight on student stress behavior versus misbehavior. That's a brand new session, and it looks like it's actually sold out, and I suspect that some of Maria's intended participants may have jumped ship at the last minute to join that new session, and that may explain why we have a fairly small group tonight. But in any case, I can tell you that those of you who have chosen to participate in Maria's session tonight won't be disappointed. Maria is one of our most talented facilitators, and her sessions always receive the highest rating from participants, so I'm sure it's going to be a great session, and I certainly look forward to it. Et je voudrais aussi profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Comme d'habitude, cette session est en anglais, mais si vous désirez obtenir des informations en français par la suite ou nous contacter, surtout n'hésitez pas à m'envoyer un courriel. We are definitely thrilled to have each and every one of you with us tonight, and it's also an absolute pleasure to welcome Maria Van Vallis. Maria is a member of the Critical Thinking Consortium, also known as TC Square. She has taught at a variety of levels and has extensive experience in integrating critical thinking in the classroom. I've moderated with her a few times in the past, and I must confess that she's one of my favorite facilitators, and I certainly look forward to a great session tonight. So please don't hesitate to intervene. We have a small group, so jump in anytime you want to chat with Maria. And yeah, so that's pretty much it, Maria. So go ahead and take over, and I'll be there to help you if you need.
Thank you so much, Michelle, for that really generous introduction. And I'm so happy to be here always with Ontario's dedicated educators. You know, I'm consistently reminded of despite a lot of challenges that we face in education, what a rewarding profession it is. And when I get to be in sessions with dedicated teachers, it's just always just a thrill, really, to be here and just learn together with you. So I did want to ask participants how many have been in a session with a facilitator from the Critical Thinking Consortium before. And if you just wanted to use the polling tool that Michelle introduced earlier, that would be great. So how many have been in a session with a facilitator from the Critical Thinking Consortium? Okay. So far I see 2. I do recognize a few familiar names, which is really nice. Okay, so quite a few of you actually, which is fantastic. And how many have been in a session that I have run before? Maybe we'll clear that.
I just cleared everything so Perfect. You can start again. Yeah.
Perfect. Yes, great. I know, Shasta. I worked really hard to get TDSP partnering with us, so it's really happy that that's happened. Okay, so we have half and half. I wanted to say, because, you know, in the sessions, a couple of things. Because we always have people who come like with different levels of experience with our framework, there are some key foundations that I always like to make sure that we address. That being said, I also find that even if there are some things that are repeated, that each time it deepens. Many participants tell me it deepens their understanding. Sometimes people say, you know, we've done the critical thinking thing, and I guess for myself, thinking of the journey, I find that it's so iterative, and there's always more that you're learning and going deeper into. Also, I wanted to say that this presentation is very similar to the one I offered in the spring, because it was requested that I offer a similar session. So I just wanted to put that out there in case there are some who are in that spring session on intermediate math inquiries, that we will be exploring very similar terrain. But again, I hope that you'll be able, through revisiting some of the ideas and seeing them, that you'll gain some different perspectives on the work. Now, I'm not sure how you're all feeling at this point, but I know, you've definitely finished report cards. I know what it's like when those holidays are in sight. So I'm wondering how many of you put a check mark if you feel like the owl on the left, and an X if you feel like the owl on the right. Where you're most feeling. I know it might not be exactly one or the other, but I should really have this along a continuum. If I'm making this a true critical thinking activity, I should really have a continuum and say, on this continuum, where are you? But I just want to acknowledge, again, the hard work that you're doing, and that you're here tonight continuing in your own professional learning. And what I wanted to say is, I know that you have probably a gazillion things that you need to do, but to use this time, this next hour and a half that we have together, to just nurture yourself as an educator, your own learning, your own thinking, and to take that time where you're nurturing yourself. And I hope that in this session, I'll be able to provide some of that for you. I wanted to ask you, because this session's really focused on this concept of habits of mind, which comes up again and again. We're talking about the habits of mind of our students. And I wanted to ask, which habit of mind do you notice? So thinking about the context that you're currently in, which habit of mind do you notice your students most need additional support in developing in mathematical context? And if you want to use the writing tool and write directly on the screen itself, or feel free to put your comments in the chat box as well.
The writing tool is the tool located in the fourth position on the vertical tool strip. It's a little A. So you can just click on that little A and you can start writing on the screen.
So, and we're thinking about, those different habits of mind. As you think about your students and they're engaged in a mathematical challenge, what are you seeing in their thinking? What are you seeing in terms of their ability to engage with the problem? So someone has put persistence. Definitely. Any others that people wanted to share? Communication. Perseverance as well. So just being able to think through the question itself, yeah. And communicating with clarity and precision, absolutely. If it's hands-on, they don't initially think using numbers. Thank you. So, these are really important things that you're surfacing about your students. It's interesting because the research on student thinking in mathematics is continuing to highlight 3 key habits of mind that students most need to develop in order to think like mathematicians, in order to experience more success in mathematics. And they are perseverance, attention to detail, and open-mindedness or flexible-mindedness. So this idea of being able to look at a situation from multiple different perspectives and be open-minded, like looking at the different ways that they can work with numbers, or different ways of solving a problem, or different ways of seeing or visualizing the context. So those are the three key habits of mind: perseverance, attention to detail, and open-mindedness or flexible-mindedness. So that's what I'd like to focus. We're going to focus on quality thinking in general, but one of the threads through our presentation tonight is really on how do we more explicitly create opportunities for students where they're being required to persist, to be open-minded, and to pay attention to detail. How are we providing feedback that supports them in developing those habits of mind? And how are we shaping a climate where these habits of mind are expectations in our classrooms, and that we build those expectations through routines, things that students are routinely asked to do through consistency. So that's what I'd like us to tap into tonight. I love this quote. I use it in most of my math presentations because this was really an important understanding for myself, is no matter how patiently or clearly we explain, and sometimes we put a lot of our effort into that as teachers, we can't do the thinking or learning for our students. The one who's doing the thinking is the one who's doing the learning. So how do we create those opportunities to invite students into that kind of thinking? And then when we create these opportunities, how do we scaffold and support them so they can actually enter into those challenges and be successful? A question I wanted to have us thinking about throughout the time that we're together tonight is really, how do we nurture habits of mind through the effective design of critical mathematics inquiries? So how can, as we pay attention to the design of those opportunities, how might that help to nurture the habits of mind? And I wanted to take a moment. Actually, there is a small group, so I wondered if we could just go down the list really quickly, and you could tell us just who you are and what you're teaching this year, and maybe just a little bit of what you're hoping to get out of the session tonight. So maybe if we could start with Carol. You can just use the talk button at the very top under the video there, the screen.
Just jumping in for a second, some of you may not have a microphone, so you may just have a headset or speakers. You may not have a microphone, and if you want to share your questions and your ideas in the chat box instead, that works as well. You know?
I'm an occasional teacher, and I do teach intermediate mathematics.
Thank you. Great. Gloria, did you want to go ahead or write in the chat box, whatever you're comfortable with? So Madison, grade 10 applied, difficult to keep them engaged, less attention span, lack of interest in math in general. For sure, that student engagement piece is often a really critical piece. Does anyone else want to jump on the mic? Andrew, occasional teacher, K-8. Thank you for being with us. Yeah, Madison, I hear you. There's, again, the question that, like, in that moment when we're having a class that's challenging us in certain ways, sometimes having that inquiry stance of, you know, what is it that these students, what do they need most to nurture their thinking? And we'll look at some of that tonight. Please, everyone else jump in on the mic if that's easier. Kit is a coach working with intensive support schools. And Kit, I know we were
in the Reflections on Practice together. I think you were a facilitator in that amazing program that I absolutely loved. Patty, you're an intermediate math teacher at Beaver Brae Senior Elementary School in Kenora. By the time they reach intermediate grades, absolutely they've learned to be fearful and intimidated. Oh, and it's amazing. You're striving to bring the wonder back in mathematics. That's fantastic. And I'm sure you're using some of Jo Boulder's amazing work with the mathematical mindsets and her week of inspirational math, just to kind of open them up again. Yeah, I know, I just absolutely love Jo Boulder's stuff. Did anyone else want to jump in? Samantha, grade 8 math, teacher candidate Queens, fantastic. Trying to overcome math anxiety or overcome math. Yeah. Thank you so much, everyone, for joining us. Again, if you want to continue in the chat box, I'm going to move along, but we'll get a sense. Yeah, thank you. Absolutely. The joy and fun in numbers and mathematics. And I also think, too, I think that one of the things we're going to explore is how when we intellectually engage them and balance supporting them and scaffolding them and developing these tools of thinking so that they can feel successful, it's really transformative for students. So I'm hoping to show you examples. And I just wanted to invite you as well with our question tonight. This is just a little thought book that I put on, but our question on how do we nurture habits of mind. If you wanted to start a little thought space for yourself where you start playing with this inquiry question and thinking about, you know, the design of critical inquiries and how they might support perseverance, attention to detail, and open-mindedness. So I wanted to encourage people to take that, because we'll revisit our question, and I'll give you a little time to, you know, to gather some of your thinking as you're doing that throughout this presentation. So this issue of engagement came up, and this is the taxonomy that we've developed at the Critical Thinking Consortium. And in any taxonomy, what's implied is as you move up the taxonomy, you're actually doing the things that came below it. So what you see here is we've got this sense of engagement where are students just on task? Are they interested or entertained? Are they caring about what it is we're engaging them with? But in terms of challenging the students and actually transforming or empowering them, it's really through creating opportunities for critical, collaborative, creative, and conceptual thinking that students can become engaged and transformed in the learning. I'm just going to say, I think that somebody still has their mic on. It might be Carol. I'm going to ask you just to turn that off, only because it creates a little bit of feedback. Thank you so much. So this is something to help us think about engagement, intellectual engagement, and where we're aiming in our classes. But the big question that comes up is, well, we can create engaging tasks that are rich in critical thinking, collaborative thinking, creative thinking, conceptual thinking. But the question we have to ask ourselves is, why aren't students rising to the engaging tasks that we set? And so those two things go together. One, making sure that we're engaging them, but secondly, thinking about what is it we need to do to actually support them in rising to those challenges. I think this from the research of Resnick in 1989. I'll just give everyone a moment to just take in that quotation. And if you have any thoughts about this, whether you agree or disagree or anything that it sparks for you, please at any point during the presentation, I know there's so much rich knowledge and experience in this group, and I want to make sure that you know, people are gaining from each other. It's, you know, we've had these math wars, this conversation about math wars. I think this idea of you know, what's been called discovery math, or inquiry math and then the basics, and this kind of tension. And I do think that any learning, including the learning of the core concepts, the core background knowledge in mathematics, is enhanced when what we're doing is inviting students to think the way a mathematician thinks. And that in some way, starting to think about what we do in our classrooms as nurturing mathematical thinking and doing that through the curriculum. So shifting a little bit of the mindset of sometimes we get caught in this, I need to cover the curriculum, and we feel that pressure, and there's some and I understand there's very real constraints and issues that we're negotiating and having to make professional decisions around. But when we step back and start to think about, rather than the topics being what drives our planning, to make the thinking, the core mathematical thinking like a mathematician, what the key disposition is we want to be nurturing, and then we do that through the curriculum itself. I'm just going to get this comment here because I want to make sure we get this richness. So Kit's saying how important it is for students to understand the story of the problem, being able to visualize what is needed, not just for word problems, but for strictly numerical questions. Yes, absolutely need to stop and think and reflect before getting started, and continue to be thinking as they're working through the problem itself. So this came out with the Canadian Educational Association. They did a large national survey in 2009. What did you do in school today? And the results were quite interesting. When they were talking about intellectual engagement, students in grade 5 were 84% intellectually engaged in learning. And by the time they got to grade 12, it was essentially half that. So it was about 43% that students felt engaged, intellectually engaged in school. Students still felt a sense of belonging and engagement. They wanted to go to school. They loved, the social and participating in various things. But this piece of intellectual engagement, and again, I like to include this in the sessions that I do because I think it's really helpful. When we as teachers have that sense of, why aren't the students? What's happening? Why aren't they engaging? And we see that if they have the skills, or they don't have the skills to engage in a challenge and we're not challenging them, they'll feel very apathetic. If they have a high degree of skill and we're not challenging them, they'll find that what they're doing is boring or has little relevance. If we're challenging them but they don't have the skills to engage, they're going to feel apprehensive and anxious. And that sweet spot in the dark orange, that's that flow. That's that, they're 100% engaged when they're building the skills and they're being challenged. And as they get the challenge and as they increase in their skills, they feel very interested and successful and get caught up in that learning and become empowered when we go back to that taxonomy. I just wanted to take a moment. And again, some of you who've been in sessions have seen differentiated these questions before. But just we'll do this a little more quickly. But looking at these type 1, type 2, and type 3, if you can write in the chat box what you see as being the key differences between the type 1, type 2, and type 3 questions. And so in that first box, it should say, where would you put them? Okay, sorry, Madison. So my question is, what do you see as being the key differences between the type 1, type 2, and type 3 questions? So you might even want to compare in a row, look at the form of that particular idea as a type 1, the form in the type 2, and then the form in the type 3. So some people are saying type 1 more knowledge-based or closed, I saw. Type 2 more metacognition. Type 3 are open. Type 3 open-ended. Yeah, a range of answers and entry points, as Samantha says. Type 2, thinking questions. I know I want you to look at the type 2s for a second. So let's think about your answer to the first question. Do you enjoy finding patterns? What might be your answer to that question? What kind of a question is that? Right? Or what object would you prefer to use to estimate how long this table is? What do you find easier when working with fractions, knowing the whole or the part first? I guess my question is there a right or wrong to those type 2 questions? Yeah, absolutely. They're more opinion-based. They're more personal preference. There's not really a right or wrong there. The type 1 are definitely more of the there is a right answer. There's a definitive right answer, and it's a matter of figuring it out or looking it up or, solving the question itself, right? There is a right answer. But as many of you are surfacing with those type 3, there are multiple plausible options to the type 3 questions. It doesn't mean that all answers are sound answers, but there are multiple plausible sound answers. And it's a matter of doing some investigation. It would require some investigation, some curiosity. You definitely have to pull in background knowledge to solve, or again, do some investigation to figure those out. And then you are going to have to justify your answer in some way using evidence, right? In order for your answer to be sound, you will have to justify it using evidence. But it's possible that two students in the class, one could have one answer and justify it with sound evidence, and another student could do the same, and both would be acceptable, right? And when we think about mathematics, so often, traditionally, we think of that continuum. We have tended to stay more in the type 1 kinds of questions. And I think one of the unfortunate consequences of Bloom's taxonomy is that Bloom's was actually meant to be an assessment taxonomy, which means that when we were evaluating or creating, it implies, similar to our engagement taxonomy, that you're able to do all the things below it on the taxonomy. And it was meant that when you're evaluating, you knew when a student was, when you're assessing and a student was evaluating something, you were able to recognize and see all that they have pulled in. But somehow the taxonomy got translated into a teaching and learning continuum, and almost like these building blocks rather than a true taxonomy. And so the idea is, well, you have to teach a bunch of stuff first before you can get students thinking. And I just want to challenge, like gently challenge that idea that can we know anything with any true depth or understanding without thinking about it first. And this is an equity issue, because when we think about, as students transition to high school, and some of our students are in applied courses, a lot of times what has happened in applied level courses is that they've stripped out some of the, quote, higher order thinking verbs. And when we think about that from an equity standpoint, what are we saying? Do we not want all students thinking, and thinking rigorously? But perhaps what they might need is some different kinds of differentiation in terms of perhaps the complexity of the question or the number of concepts that they need to consider. So just something to think about with those type 3s and how we can start building those, but scaffolding them, I think, is the key. So when we're talking about quality thinking in math, and we're talking about critical thinking in mathematics, it's emphasizing the idea that math requires thinking for yourself, that we can help students develop metacognitive and self-regulation skills that support learning, and we'll talk about that, and that we have more options for adapting instruction to meet the needs of students. So if we're going to give them those type 3 open-ended questions, there are definitely things we're going to need to do to adapt, choices that we'll need to make to ensure that students can enter in and be successful, right? Because I know that what we, sometimes when we see those and we think about our some of our very particular students, and suddenly it goes, I'm not sure how is that student going to enter into that? And that's the question, right? The question is, what is it we can do to build that? The definition that that's been developed over 25 years with various stakeholders in education at the Critical Thinking Consortium. And again, this is not the definition of critical thinking, but it's a pedagogically useful definition. We're thinking critically when we're thinking through a problematic situation about what to believe or how to act, where the thinker has to make a reasoned judgment that reflects the competent use of the intellectual tools for quality thinking. So we're presented with this problematic situation. In order to engage with that, we have to employ our reasoning. We have to make a reasoned judgment. But in making that judgment and making that decision, right, that's ultimately what we're doing. We're making a series of decisions. And in making a reasoned decision, a reasoned judgment, we're actually pulling upon the use of these intellectual tools. So what I'd like to invite us to think about, I'm going to show you what those intellectual tools are. And again, this is going to be a revisit for some of you who've been in the sessions before. But those intellectual tools become a very, very powerful framework for assessment and differentiation. So let's look at that, right? A person's thinking critically if they're judging or making choices among options in light of criteria. So that's one of the key intellectual tools, is what criteria are we giving students to help them make a good decision? So for example, I'll just give a little example. We're going to be looking at a number of examples over the next hour. But if I say to students, I want you to provide a solution to this question, I've given them an instruction, but I haven't given them a clear direction for decision making. Whereas if I suddenly add some criteria, I'd like you to design an effective solution, and we unpack that criteria of effective as including the characteristics of your solution needs to be organized, it needs to be accurate, and it needs to demonstrate a deep understanding of the math, right? And it will take some time to really help students develop that understanding. But thinking about this difference between, okay, I want you to hand in a solution to the problem. What is it we're essentially implying to students? We might unconsciously, unintentionally be saying to them, I just want you to get this done, and the quality isn't that important. Or you're saying, I want the right answer, again, unintentionally. But when we say I want an effective solution and we work with the students and we have an anchor chart about an effective solution, we've now given them the criteria upon which they will assess and decide, so that they can look at their solution and say, is this organized? Is it accurate? And you start building in them independently being able to assess their own work. That's one of the outcomes of using criteria on a regular basis and supporting it and scaffolding it and helping them internalize the criteria is that the quality of the work improves. When we're creating that thinking math classroom, it's the classroom where students are learning to think. They're learning how to engage with these intellectual tools, and they're thinking in order to learn. So they're being presented with these problematic situations where they need to make sound decisions. And in doing that, in thinking as the methodology for learning, they're actually deepening their understanding of the subject matter. And they're engaging with it intellectually from a more rigorous place in a way that actually gets them more caught up because they are being intellectually challenged. So this framework of the thinking classroom, we're going to explore in more detail tonight creating opportunities for thinking. So in the top right quadrant, we'll touch on the other three, but we're looking intentionally at design. But I like to think of this too as the kind of a thinking ecosystem. So when I'm trying to create that thinking classroom, I'm thinking about what kind of climate am I creating that supports thinking? So for example, if I have an expectation in my classroom that students are to make up their own minds, right? Or students are to become independent problem solvers, if that's an expectation in my classroom and a climate that I'm trying to create, then I need to create a routine. And a routine could be ask three before me, right? That they ask others before, that they start to think and figure out what it is they need to know. It could be a simple strategy like think, pair, share that shapes a climate that supports thinking in students, where they're regularly given the wait time to grapple with a question, right? There's many, many different ways that we can build in through routines the shaping of the climate. If we're trying to build the perseverance, the open-mindedness, and the attention to detail, again, how are we shaping a climate where it's a very clear message that that's what's valued? We're also creating those opportunities for thinking. We're providing those rich critical inquiry questions, which is going to be what we're going to dive into. We're building their capacity to think by supporting them in those 5 intellectual tools you see at the bottom. So when we think about those questions, those type 3 questions from earlier, students needed to draw on background knowledge. So you can start to use that as an entry point for differentiation and start to say, okay, or see in students through observation, conversation, various small little assessment strategies, maybe they're missing the background knowledge and that's the issue. And so maybe with that group of students, you need to review fractions, for example. You need to review something about fractions that they need or integers, that's the background knowledge piece that they're missing. Is it that students need the criteria for judgment? Upon what basis are they making decisions along the way? The vocabulary of thinking. So are we using words and supporting students in developing vocabulary like conjecture, like proof, like hypothesis, like reasoning? Are we bringing that rich mathematical thinking vocabulary and explicitly teaching it to students so that they can enter in? When we ask students to justify their solutions, do they know what that word means? And do we need to is it really worthwhile to spend the time supporting that in students? Thinking strategies are thousands of different organizers and ways that students think through a challenge. It's anything from if they're trying to decide between which proof is most accurate, it could be a pro-con chart as a thinking strategy. A number line is a thinking strategy. There's a Venn diagram as a thinking strategy. There's really thousands of different thinking strategies that we employ to help us think through a challenge. So maybe sometimes a student needs that, an organizer in some way that supports them in thinking through the mathematics. And finally, those 3 habits of mind, that's the focus of tonight, is, in mathematics, we're looking at perseverance, attention to detail, and the open-mindedness or flexible-mindedness, because we notice that those are some habits of mind students really need to develop. So how are we nurturing that? And that the guidance, finally, the guidance that we're giving students to inform their thinking is connected to, that the guidance is actually connected to those intellectual tools, right? So that you are able, as you're seeing students struggle, you're thinking through, okay, this is an issue of perseverance, so the feedback I'm going to give is going to be connected to perseverance. Or I'm seeing that the student doesn't have an accurate understanding of conjecture, so the feedback and support and guidance I'm going to give is around that vocabulary, and that we can start to use those intellectual tools as tools of differentiation and assessment. I'm going to just pause there. I just want to check in with everybody and maybe give me a thumbs up or a yes or a no if how things are proceeding. Am I being clear enough? Do you need me to slow down? Is this making sense? Just wanting to check in with the group because I'm not able to see your faces to know how any of this is landing. If you have any questions, something you need clarified, again, please don't hesitate to step in at any point. So the attributes of a critical thinking question or task is one that provides or generates options. That's really key, right? There's multiple plausible options. That's what makes it a true critical thinking question. It requires reasoned judgment. So students have to arrive at judgments, conclusions, and decisions that are reasoned. They are using criteria in order to decide, and they need to use evidence to support their judgment. So those are the attributes. Again, this will all be available on a PDF after the fact as well, so that you can refer to these. Because I know it's a lot to take in. But let's look at some examples now of some critical thinking tasks. So when we're thinking about critical inquiry, how does it support students in engaging with mathematical processes in meaningful and authentic ways? So we're looking at reasoning and proving, we're looking at problem solving, we're looking at visualizing, communicating, so all of those rich mathematical processes that we can bring in with critical inquiry. So this is an example of a unit that I engaged students with for grade 8 on the surface area and volume measurements of cylinders, and that also included an understanding of the measurement of circles. And so what I did is the very first day of the unit, I put this slide up and gave the students this challenge to develop a reasonable estimate for the surface area of the Guggenheim Museum. And we also ended up expanding that to include volume as well, but that was the very first day. And I gave students a thought book. So it's just a space for students to start grappling with this challenge. And at first, they looked at this and they're like, what? How are we going to figure that out? And I just kept supporting them and saying, okay, so what do you need to know? And so the students said, well, you need to know, like how do you measure a circular object, right? So that was one of their questions, and surface area, let's be clear, I want to remember, what's surface area, what are we talking about? And then how do you measure irregular shapes? And so all of these, essentially the curriculum expectations cascaded out of this challenge. And what happened, which was amazing, was that students actually became hungry for the learning because now they had a challenge that they were caught up in. And it really was phenomenal to see the grade 8 sort of saying, okay, well, are we going to learn about circles? How do you measure a circle? And now they were into it. And it was such a different shift of engagement. from usually my approach would be, yes, I'll give them a rich circle problem at the end of the unit, but first you're gonna go step by step. I'm gonna teach them about how to measure circles, and then we're gonna do this. And I sort of had attrition along the way because, they weren't that engaged. But now with this, they wanted to solve it. And it was non-Googleable. You can't find the surface area of the Guggenheim Museum anywhere online. And the students would come back and say, yeah, I checked, like you can't, because they tried. So we're building all of this rich mathematical thinking. The reasonable estimate, this idea, there's the mathematical vocabulary, there's the criteria, we're building the conceptual understanding. And thinking about those habits of mind, right? Where does perseverance come into this challenge? Where does open-mindedness or flexible-mindedness come into this challenge? Where does attention to detail come into this challenge? Madison, I noticed you said that you did something like this in your class, and if you wanted to share, please feel free to jump on the mic or write about it and tell us how it went and what you did. So what was happening here too, that's awesome, your applied class went great. So again, this idea of engaging them by giving them the rich challenge, but recognizing, again, thinking of those intellectual tools that you're going to have to nurture and scaffold those intellectual tools to help students enter in, because they're going to be at different places, right? That's awesome. You gave each student a role. And what we're doing there too is we launched the birds. I didn't give the rich problem at the end. I gave it right up front. And in doing so, I'm inviting students to predict, speculate, offer initial ideas. It's fail forward, right? They're going to get all that thinking. They're going to have all of the inconsistencies and, the quote, wrong ideas, coming up. And they get all of that out on the table, right? They get to activate their schema, get their incorrect assumptions right out there, right up front. And then we're sustaining the inquiry and we're correcting some of those misunderstandings. We're providing additional teaching and learning along the way. So rather than that problem being the proof of learning, it becomes the driver for the learning, right? And so in the cascade, that's what we're doing. The task becomes the driver for the learning. And again, you see there, this is a student, and that's her thought book, right? Like you see the messiness, right? Like you see her, look at all of the rich mathematical processes that, you could pick out going on there. She's visualizing, right? She's making these conjectures. She's checking. She's revisiting. She's, crossing things out. She's rethinking. There's a whole lot of things going on. That's why the thought book is that space for that messy thinking. I don't mark the thought book. I use it in assessment as a point of observation and conversation. But it's not something I evaluate because it's really there for the students to continue to grapple with the overarching critical challenge. And then we dive into some mini lessons where we're starting to build our understanding of circles, right? So we're still addressing the curricular expectations. They're not just off looking at the Guggenheim. Now we've got to actually scaffold with the background knowledge, right? We've got to build the background knowledge so they can actually be successful in the challenge. That's awesome. I'm so glad, Shazadi, you started this thought book and your students love it. As we're building that background knowledge, as students are grappling with problems, I love Alan Schoenfeld's 3 prompts. I sometimes have created a little card for some of my students who particularly need the support and laminate the card, and we keep it on their desk. And as they're working through a problem to build their perseverance, their attention to detail, their open-mindedness, these are the 3 prompts. So they have to stop. What are you doing? What are you doing right now in this moment as you're solving this? Why are you doing that? And how is it helping you? So they start to become metacognitively aware of what it is they're doing as they're problem solving, whether it's helpful or not, whether they need to make different decisions, right? If it's not working, if they're realizing, no, I'm writing everything out and there must be a simpler way, but I'm just kind of, this is what I'm doing because I don't know what else to do, and just to stop and help them be aware of that. It's okay, well, what else might you need here? What else might be useful? And working together to scaffold them, but building that metacognition in the students. And then, again, as we're building this background knowledge, so we're doing our lesson on the circles, but then we go back to the thought book. You'll see the little TB, right, stands for thought book there on the chalkboard. And we're asking, what's the most important connection between circles and the Guggenheim inquiry? So we're building that knowledge. We're doing mini critical challenges on circles, but then they keep bringing it back. And what's happening there is that building of the rich connections. And then, again, our anchor chart for the effective solution, that's up there on, in the classroom. We're understanding what it means to be organized, accurate, and communicates a deep conceptual understanding. And we're building their capacity to self and peer assess using that criteria. So you might have students look at a solution of one of their peers and give them this criteria and have a rating scale and unpack with them a little bit what organized is, what accurate is, have them build their schema, give them examples of organized, varying degrees of solutions, of organization and solutions or effective solutions, and get them to rate them or rank them according to which one is most effective. Help build the schema in the students so the assessment is not all on you as the teacher, but you're bringing that forward, that students are peer assessing and self-assessing as well. And that's where they're starting to build those tools independently. And that's when we know they're not so dependent on us to be that extension of their brains, but they're actually doing the thinking, independently being able to assess their work. And I just want to show you an example here. So this is a student who, this was one of those stories that brought tears in my eyes, because the student was not said, and her mother told me doesn't really like math coming into, again, these intermediate grades. We were talking about that earlier. Definitely was one of those okay, I'm just whatever, I just have to get it done. And the mother emailed me and said, I don't know what happened, but he was working on his solution for an hour, and he was so into it, and he felt this feeling of accomplishment. And you can see the quality of the work, right, and the thinking that this student engaged with. Right? And that's the power of that, the intellectual engagement coupled with the support with the intellectual tools. We get into that flow, that sweet spot, where students, you have students saying, I wasn't into it, but I got into this, or, parents giving that feedback, which is, really, really rewarding when that happens. And when we're assessing students in terms of their thinking, we're assessing using those tools as a framework. Right? So can the students draw on accurate and relevant mathematical information as they're solving the problem? Are they making reasoned judgments using relevant criteria? Right? Are they using this criteria of effectiveness when they're designing their solution or not? Did they not pay any attention to the criteria? Or is their strategy, is their estimate reasonable? Were they able to use that criteria to assess the reasonableness of their estimate? The vocabulary, right? Do you see them using vocabulary, conjecture, hypothesis, evidence, justification? Are they starting to use that independently? Are they supporting themselves as you teach them some different strategies to use? Do you then see them working independently with some of those strategies? And are you seeing perseverance? Are you seeing attention to detail? Are you seeing open-mindedness? Any questions at all from anyone in the group? Again, just wanting to check in because I can't see everyone. anything you wanted to share with regards to how you are assessing thinking in your own classroom. Again, feel free in the chat box to add your thoughts as we go along. Yeah, I appreciate that. There's a lot. There's a lot. So I appreciate that. And again, I will put the PDF after the fact so that you can look at this and have those examples and think about it. Yeah, it is different. It is different. And you know, I will share a story because I think it's and I share it. I share this story. You know, I wanted to first of all be really transparent that when I got my assignment of teaching math over a decade ago, math was not, like, I was a good math student, but math wasn't something I pursued in university. I did not consider myself a math expert, and actually I had some anxiety about teaching math, you know, because of that. But I really dedicated myself. I was very determined to not pass on, you know, the math anxiety. I kept searching. I went to so many different professional learning sessions and, you know, trying to really build a pedagogical approach to engage students. And I really want to credit my colleague, Laura Jeannie Newman, who I think has done some really beautiful work with conceptualizing math. And as I began to incorporate and really bring this thinking approach, I felt so alive in the classroom. Like I was engaged, you know, like I couldn't wait to come in and do things because it increased my sense of efficacy. I felt I could support students more effectively. And it was interesting, this year I had a tutor of a student who got my information from a parent and said, I need to know, like, I need to talk to this teacher because I've never seen this approach, and this is, like, I'm noticing how independent the student is as a mathematical thinker. And for me, that was a really special moment because of that journey. Again, not being the math expert, but just committing myself to sound pedagogy. And I think this is for all of us, you know, as math educators, when we get the pedagogy right, it's incredible what starts to happen. Yeah, it's the tools. Those intellectual tools start opening up a whole world. Like to me, it transforms the classroom because you're now, I'm not just giving them the engaging challenge, but I now have these really concrete tools in my mind for assessment purposes, for differentiation purposes, and I'm much more clear on what a student needs and how to move them along. And that's what's made the difference. So again, just thinking about our question, how might we nurture habits of mind through effective design of these inquiries? I'm going to give you another example. This is also a grade 8 algebra challenge. So, you know, algebra, and I also, one thing I wanted to say too, I do think real world examples are wonderful. And you know, when we bring those in, but I don't think there's any formula or approach that I wouldn't use sort of uncritically or unreflectively. And my point on that is to say that sometimes the rich conceptual thinking can be engaging too. Like, this isn't a real world problem in a sense. I mean, it could be, and I could make it that. But I also don't want to discount that if we teach really, if we teach conceptual thinking explicitly in a scaffolded way, it can also engage students, you know, and so not, you know, there's a continuum. Again, yes, real world examples are wonderful, are engaging when we can do that, when we can bring that in, but to not also shy away from conceptual learning, because it also has a beautiful quality of engagement to it. So this was an algebra challenge, and actually it was a little more difficult than this. The left side was actually the whole problem was over 2, like it was divided by 2. That was an extension that was done. But I introduced this on the first day, and more so than the Guggenheim, I did it after the Guggenheim, so students had experience with the approach. But a number of them at that point told me, I said, how do you feel? And a number of them said, I feel really anxious looking at this, right? And so we unpacked that a bit, and we talked about what could that scenario represent? Like we tried to connect it to the real world. What could 5 times 3x plus 2, like we spent time looking at that. But again, in their thought book, on the first day, they were ranking these mathematical ideas or concepts. And some of them were like, I don't know what that is. And I said, that's okay. So I said, just based on what you know now, what you understand in this moment, how would you rank them? And again, just letting them fail in that sense, like put it down, activate the schema, activate what you don't know. Let's get it all out. Let's get it all messy and out on the table. And then we're going to choreograph a learning experience where we're going to build. So, sorry, the tool to the achievement chart. Yeah, that's a really interesting question because, we're actually presenting at these assessment, the assessment forums that are happening across Ontario, because in our estimation, when you have knowledge and understanding, thinking and inquiry, communication, application, we don't think it makes sense that thinking is a separate category. I don't know that you can understand anything without thinking about it. I don't know you can communicate effectively without thinking about it. I don't know you can apply anything without thinking about it. So really, thinking infuses all of these achievement categories. And if you took thinking and just made it inquiry, that makes sense. And that thinking infuses all of them. So, what we'd like to see is that you can use these tools across all of the achievement chart categories, not just, it's sort of a funny thing to isolate thinking in that way. So, yeah, absolutely. You can't understand anything without thinking. So this is our point. So, going back to this challenge, getting the students to grapple and notice what is happening here. We've got a fairly complex, especially when you add the division dimension to the left side. You've got a fairly complex question. Sorry, I'm not sure what happened there. I've just had my screen go black. I don't know why. Oh, there we go. Okay. So you've got the rich algebra question, but notice the actual task isn't to solve. They will have to solve that. But the actual critical challenge for the unit is to order those mathematical ideas along the right side from most to least important. So what we're engaging the students in is to have to deeply understand those ideas over the course of it so that we're not just focusing on procedural understanding, right? How you solve an algebra question, you do this and then you do this and then you do this and then you do this. What we're trying to do is surface and pull through what these concepts and ideas actually are, and so they build an understanding as they apply them. Yeah, absolutely. The students do a great deal if they're talking to each other, right? We talk as a class. Absolutely. You get in many different ways. You can choreograph that depending on who your class is, and that's a decision you'll make. Do you want them writing first, then sharing? Again, I don't think there's a formula. I think it's more of a stance, and then you decide based on your context. Okay, so let me that's a really important question. How do we support students with low EL without feeling separated? So it's a great question. Again, so what I So what I might do, definitely a lot of the math talk, and also I might make the decision, not separated, but that I might differentiate according to, you know, what it is sometimes that they're being asked to do, so not separate, but maybe you have them taking, grappling with the larger question, but then what they might need is just more intentional scaffolding, right? What they might need is, right, they can have like different ways to show their understanding, that they might sometimes explain some things to me orally rather than through writing. So there's different ways to differentiate without necessarily cutting them off from the rich thinking. They just might need something different to explore that thinking. So I'm going to show you an example of a lesson that's scaffolded for this challenge. So one of the places we went, and I co-planned, co-taught this with Laura Ginny Newman. She came into my class and we did this together. Yeah, absolutely. A simpler equation, just to go to your point, Debbie, a simpler equation as well to possibly not overwhelm them. And again, you're going to make that decision based on, you know, how that will land with them, how that makes sense in the context of the class, getting them to say, like, maybe saying, you're going to go back to this challenge, but here, why don't you try this first, right? And then you could scaffold, and then they might still, like, so that they're not cut out of the process, that they might still want to return to the challenge. So what I have on the slide here is an example of an anticipation guide, an anticipation task that we used when we wanted to explore the concept of like terms with students. So what you'll notice is the pre-learning, we gave students this, okay? And in a group, they had to agree or disagree with the statement and justify. Okay, so we tried to take common understandings and misunderstandings about like terms and put all of that up front, get them grappling with that up front. Right? Do you agree, disagree, what's your justification? Then we did a concept attainment lesson on like terms. And I love concept attainment strategies in math. They can be so powerful. So giving them the yes examples and the no examples. And then with the students, we were writing, like, what are the attributes you notice about the yes examples? What are the attributes you notice about the no examples? Right? And those attributes, you start to build in them. Guess what? That becomes the justification when you have them revisit the anticipation guide at the end of class. Right? So you're helping them build a justification by exploring the attributes. Right? So they pick up that, okay, well, like terms all have the same variable, they all have the same exponents on the same variable, they all have a coefficient, but they do not have to be all of the same nature or the order of the variables, right? And you're starting to build that in them. So then they revisit this anticipation guide, but this time you'll notice it got a little cut off, and I apologize for that. You'll notice then they do it individually. And that's an exit ticket. Yeah, you absolutely build all the attributes with them during this. So as we were writing, that was coming from them. So all of those attributes was coming from the students as they looked at the yes-no examples. Then you have them revisit this. You get an exit ticket. You get this rich data. There's assessment, right? There's assessment. You just look at it and you get a sense of who's understanding like terms, where are we, where am I going to go tomorrow based on what they came to here. Right? So we're scaffolding that learning, and then it's applying back, because now after we do the lesson on like terms, they go back to the question and then they start to have these aha moments. Oh, yeah, like I was getting stuck when I first tried the question, but now with like terms, I can do this. And what we're doing there is we're helping students experience mathematics that's consistent with the way mathematics is done by mathematicians. because they're not just memorizing a procedure. They're applying conceptual understandings to the problem, but we're scaffolding them to build those conceptual understandings. Right? What do successful mathematicians do? Here's some things that they do. And why not make this transparent to our students, right? Make the thinking like a mathematician what the expectation is in your math class, right? I'm expecting you, and we're going to learn together. I'm going to support you to be able to visualize. I want to support you to draw inferences, to be able to ask questions, to build your background knowledge. And it's amazing what happens when we start to actually explicitly teach the tools to the students, and we start to teach this tool of background knowledge. And wow, they start to realize, oh, it's not that I'm bad at math. I just need to build more background knowledge. And they start to recognize that that's what the issue is, as opposed to this innate fixed mindset, that they don't know how to do it. And it starts to open them up to, oh, right? And even as the students are in intermediate grades, that you provide them with self-regulated ways of building background knowledge. For example, Khan Academy. That's a great, introducing that, to students as a way of, hey, if you need some extra help, if you're realizing, ooh, my understanding of fractions isn't as sound as I thought, and the class is not, maybe I need to build my background knowledge through Khan Academy or through some of the online quizzes and some of those practice pieces, that are considered rote, but that when taken in the context of building background knowledge that they're applying is actually forming rich connections, is not separated. And that's what mathematicians, they've been so critical of the way math has been taught over the last number of years, because they say it's like you're getting someone to play scales, like equating it to music, playing scales all day long and never hearing the full composition. Not being able to see the full composition of the language of music, but in this case of mathematics, right? So it's saying, yeah, we need to practice and do maybe some drills, but let's look at in the context of background knowledge, and that's this alone is not math. The mathematics is this rich thinking. Yeah, homework help, TVO, fantastic, or the math help that the Ministry of Education does as well. And here's at the end, the write-up is, instead of, I just want you thinking of the comparison of that question and a student solving the question versus what kind of learning has happened when the solution is actually just a piece of them solving the question, but what you really ask them is to rank order, right? According to the concepts necessary to solve the challenge. So the students, there were multiple plausible options. Some students had simplification first, right? And then distributive property, or first simplification, then bed math. But they had to justify it. And they had to justify it, and in that, it was needing to understand its application to the algebra. Right? And I just want you to notice that if we're looking at thinking like a mathematician, we're going back to those habits of mind. How has this challenge nurtured perseverance, attention to detail, and open-mindedness or flexible-mindedness in the students? How has it built and supported the development of the intellectual tools? How has it supported background knowledge? How has it supported criteria for judgment? How has it supported developing thinking vocabulary? How has it supported thinking strategies? So, again, the difference between teaching in a procedural way, the algebra, versus framing a rich critical inquiry and what gets surfaced. But again, our responsibility then is to scaffold and support the students to enter into it. And again, just to kind of see some of the student thinking here. where they went. And this is grade 8. I'll just give you a moment to look at that. And if you want to make any comments, please feel free. So again, this shift, just want to come back to that. Making thinking like a mathematician what my math classes are really about, but doing that through the curricular expectations. Rather than the curricular expectations driving my pedagogy, I make the rich thinking pedagogy drive our journey through the curricular expectations. And this is I'm just going to get you to read a student's voice here. And at the particular program that the students did refer to us by our first names, it was an alternative program. So just in the students' words, what they gained through this experience. Yeah, there's a real metacognition reflection going on there. And this is, and this is a 13-year-old, right? And I think sometimes we do underestimate what students can do. But when we scaffold and explicitly teach these thinking tools and these ways and approach it in thinking like a mathematician, they can really rise to that. And this was another student's reflection. So how do we get them off that trajectory some of them are on when they come to us in the intermediate grades where they don't like math, and instill in them a confidence, right? That that now independently they will have that as they approach problems. They won't be dependent on me, their teacher, and the great way that I explained it. I don't want them to be dependent on the, I say that in quotes, the great way I explained the math, because then they're dependent on me. What I want to do is equip them with those tools so that independently they can go forth and solve really complex problems. We're going to need our students to solve really complex problems, right? Because unfortunately, we're creating a lot of really complex problems in the world. I'm just going to get this question here, sorry. Any problem-solving model, right? Many teachers that students can use to make meaning. Yeah, I mean, there's many different ones. So even the, the understand, make a plan, carry out the plan, look back, communicate. I mean, that can absolutely be integrated. That's really George Polya's framework for problem solving, and he's a wonderful mathematical thinker. So that's a great example what you're bringing forward of a thinking strategy. Like this is all all can be pulled in as a thinking strategy. Yeah, it's not all in any article book link yet, but we are working on, we are a not-for-profit, and so some things do take time, as we develop them, but we are developing this for sure. You know, again, Laura, Jeannie Newman's been doing some really wonderful work. And we do have, for those who are partners, there are some, I'm going to get to that in a moment. I'll show you where you can get some tools for thought that have some wonderful scaffolded lessons that bring this forward. And also, actually, maybe what I'll do is I will send Michelle just a couple of little quick tweak sheets that I have for how to take a traditional question and how to tweak it to bump up the thinking. And I'll send those to him along with the PDF, and he can post those on the OTF Connect after. Yeah, exactly. See, that's a great point, what you're saying. See, sometimes what happens is we end up using a framework consistently, and so students actually don't develop an open-mindedness, and they start to think, okay, this is how you solve a problem. Whereas I think it's helpful to think about these things as tools, right? They're tools that we use. So sometimes the quadrants is the useful tool to use, and sometimes you know, the Puglia method is the useful tool to use, and sometimes the Frere model is the useful tool to use. So you know, that's what we have to make those decisions as educators, is what's the decision making students are doing, and which tool would be most helpful in building the kind of understanding that I want students to have. It's really working on complex mathematics that enables those kinds of brain connections to develop. Yes, so I'm just reading the chat. They think they need to put it there. Exactly. It's not something independent. It unfortunately can end up coming off as a sort of procedure that they're not thinking about. Whereas it's understanding, why are we using this thinking strategy, right? What is it helping us to do? What decision is it helping us to make? And again, for me, again, this piece around equity, what we practice is what we become good at. So if we have students in our classes who struggle with complex problems and struggle with thinking critically, I really believe that the solution there isn't to not have them think about it and to give them, you know, is to not give them some challenges. But I think it's about deciding, how are we going to support them in thinking through? And it could be that we shift the challenge a little bit, but I don't think the solution is necessarily that students who are struggling should then just do rote work, right? Because then they're not practicing the rich thinking, and they need, and again, it's an equity piece. Like, it's, you know, I'm really passionate about this. Like in the States, like really from a social justice perspective, they've done these studies, and in communities with students who are marginalized in particular ways and have socioeconomic challenges, they don't teach them algebra. They teach them multiplication, division, addition, and subtraction. And there's this whole project called the Algebra Project that's saying, you know, this is really unfair. Like, students just need like sound pedagogy and support to be able to enter into this. And it's, you know, there's an injustice to that, right? Like, Paulo Freire talks about this. He says, when we cut people off from curiosity and their own inquiries, it's actually a form of violence, you know? So if we never give students this opportunity to inquire and to develop deep understandings, you know, we're really not supporting our students, and we're not supporting our society, because, you know, these are our future citizens. And I'm sure you all, like, I'm sure that, you know, as teachers, we agree, like, we want to be nurturing thinking citizens, you know, and citizens who, again, are able to solve complex problems in really sound ways. Just really quickly, I wanted to share with you just a couple of sites that you might not, some of you might be familiar with and some might not, just again, of some rich tasks that you can do. So Joe Bowler's site, U-Cubed, I love this, What's the Secret Code? And what I like to do is, there's a rich task here, and I sometimes like to just wrap a little bit of a critical thinking frame around it. So I might say to them, I want you to develop, I want you to determine the most efficient way to solve this. Or, I wrap a little bit of a critical challenge around it just to, again, give them more decisions that they need to make. So that's a rich task from UCubed that you can check out. And this is the work from Peter. I'm just going to get his name again. I suddenly forgot. It's from Simon Fraser University. Peter Liljedt, I believe. And yes, Liljedt has these awesome math challenges, and again brings in a lot of the real world conceptions. And I tweak some of his tasks and just bring in a little bit more of that critical thinking frame. So I'll say create the most fair teams of 2 people each for a game of pickup, right? Yeah, thank you so much for putting that in. VNPS and VRG are also some resources that Debbie's suggesting. And I love also Open Middle. If you don't know that site, that's fantastic for intermediate mathematics. And basically what they've done is they've taken, and I don't know if most people know that Dan Meyer was actually Joe Bowler's student, but Open Middle goes on that concept, and the Open Middle site is openmiddle.com, takes existing textbook questions but takes out the middle, as they say. So it's open middle so that they become rich and open-ended, and they have some really neat thinking strategies to support students in the iterative process, like reflecting on mistakes as they're making their mistakes and then trying again. So I really suggest Open Middle. So we're getting close to the end. So I just wanted to highlight the Critical Thinking Consortium, the website, tc2.ca. And if you are a partner board, and you can find out by going onto our site and in about tc2.ca, it says list of partners. You go to see if your board is a partner. If you are, at the top right hand of the website, you can log in and create an account, but you must use your work email, because that's what triggers to our administrator that you can get behind the firewall and get access to some of the free resources that are there. And you create an account. I wanted to show you. I'm going to go back for a second. We have this Tools for Thought section on our website, and we have some existing math tools for thought where you've got rich lessons in these areas. So visualizing a math problem, analyzing a math problem and checking the solution, writing reflectively in math and science, monitoring problem-solving progress, organizing data in a table, and we have an inference lesson that has a math example as well. So those are available on our site. I will also include just a couple of free resources, those little tweak questions that I will send to Michelle. And whoops, I went a little too far. That is my email, and I'm also on Twitter, but if you have any questions at all, please do not hesitate to reach out and ask me any questions, any support I can provide you. And I want to thank you so much for spending time. I really hope that this was useful, and again, I'm just inspired by all of the dedication of you, and good luck with your students as you get through. And I hope that the little frazzled owl in you gets time over the holidays to rejuvenate and restore yourself. So thank you so much for being with OTF and with me tonight.
Yeah, Maria, I'm just going to ask you to turn off your microphone so that there's no feedback when I. Great, thanks so much. Thanks a lot, Maria. Really, again, fantastic, a superb session with a lot of extremely useful information. I always say that Maria's sessions are known for attempting to address fundamental and rather complex concepts in education, and I'm always really humbled at the end of these presentations by the depth and extent of her knowledge. She somehow reminds me of the Russell Crowe character in the Beautiful Mind movie, which is, by the way, a fantastic movie, I think, that I recommend to all of you. So thank you, Maria, for sharing your expertise with us once again tonight, and for helping us becoming better teachers and better thinkers. I also want to thank all of you for being such incredibly motivated participants and dedicated teachers tonight. A special thank to Madison and Patty, Carol and Claire and Samantha, who all contributed quite a bit this evening. And also a special thank to Debbie, as always. Thanks, Debbie, for participating so much. I can't name all of you, but I certainly want to thank you all once again for your enthusiasm and for your participation tonight. A few more slides. It's going to be very quick. This is already the last session of 2017. We are in the process of scheduling a bunch of new sessions starting end of January. So please visit our calendar after the new year if you wish to participate in future sessions. And I'm going to paste the calendar and the resource link in the chat box as well. I also, as always, would like to tell you about another opportunity that is provided by the Ministry of Education and by OTF. If you are a qualified teacher and you have completed a course in mathematics, technology, or kindergarten, you may be eligible for a $450 subsidy. And I'm going to paste again the link to that page on our website if you want to apply for that $450 subsidy. We need your feedback. As always, I would like you guys to provide us with your feedback at the end of the session. You will be provided with an opportunity to fill an online questionnaire, and you will also be provided with a link to a certificate of participation that you can then add to your professional resume. And I encourage you to do that after the session. It doesn't take very long. And if you can't, of course, you can do it tomorrow. We will send you a follow-up email with a link to all these pages and resources. But please note that the certificate of participation is only available for 48 hours after the session. So that's it. This is actually the last session of the year. I'm going to end the recording, and before ending the recording, I want to thank you all for your participation in tonight's session. And I want to wish you all a very restful winter break and wonderful holidays, and a very happy New Year to all of you. So, bonne fin de soirée à tous et à toutes, et à l'année prochaine sur OTF Connect. Merci beaucoup à tous.